Hello everyone, my name is Bipin Chorosia. Today in this session, we are going to discuss about assembly programming language. So without wasting time, let's start. What is the assembly programming language? So basically, assembly programming language is a low-level programming language that is designed to be easily translated into machine language. It provides a way to write a program that can directly control the computer's hardware. So basically, this assembly language is the human readable representation of machine code, which is in the binary language that computer understood. In assembly language, each instruction corresponds to a specific machine operation, such as moving data or performing arithmetic operations. Assembly language is important in microprocessor because it allows programmer to directly access and control hardware and to write a program that are highly optimized for a specific task. Just we can imagine a futuristic world where human and machine work together, and assembly language is the bridge that provide a connection in these two words, allowing us to communicate with machine at a fundamental level. With assembly language, we can unlock the true potential of microprocessor and create a powerful application that push the boundaries of what is possible. Each personal computer has a microprocessor that manages the computer's arithmetic, logic, and control activities. Each family of processor has its own set of instructions for handling various operations such as getting input from keyboard, displaying information on screen, and performing various other jobs. These set of instructions are called machine language instructions. A process understands only machine language instructions, which are a string of ones and zeros. However, machine language is too obvious and complex for using in software development. So, so the low-level language assembly is designed for a specific family of processors that represent various instructions in symbolic code and a more understandable form. Moving to the next slide, let us discuss about the uses of assembly language. Under this, we can discuss many points like faster performance, small code size, low-level control, performance optimization, embedded system, and also access to specialized instruction. So let us discuss one by one. If we discuss about faster performance, so in this assembly language allow developer to write highly optimized program that take advantage of the full resource of the computer, resulting in the faster and more efficient code. If we talk about the size of the code, assembly program are generally smaller in size that smaller in size than equivalent program written in high level language. This is useful for application with limited memory or storage space. If we talk about performance optimization, so assembly language allows programmers to have a precise control over the hardware resources of the computers, such as the CPU, register, and memory. This level of the control enables fine-grained optimization of code to achieve maximum performance. And if we talk about embedded system, then in this we can say about assembly language is that assembly language is commonly used in embedded system where the code needed to interact directly with the hardware component like micro microcontrollers and device within limited resource. And if we talk about access to specialized instruction, in this assembly language allow programmer to utilize specialized instruction and features provided by the underlying hardware architecture. This instruction can perform complex operations or access specified hardware features that are not directly available in higher language. If you talk about operating system development, so building an operating system or writing critical component of an OS often requires working with assembly language. Operating system interact directly with the hardware, and assembly code is necessary to implement low-level functioning like interrupt handling, task scheduling, and memory management. Now let us discuss about the register and the memory. So we can discuss about register and memory in the context of function size and capacity, access speed, uses, and scope. Let us discuss one by one. So first point for this is function. So register a small high speed storage location directly integrated into the central processing unit. They are used to hold data that the CPU need to operate on quickly. Memory, on the other hand, refers to the larger storage space internal to the CPU, which can hold a much large amount of data but with slightly lower access time. If you talk about the size and the capacity, then registers are typically limited in number and size. A typical CPU has a fixed number of registers, each with a specified size, whereas in the case of the memory, this is not so. So, if you talk about the access speed, then register the faster storage element in the computer system. They are physically located with the CPU and can be accessed with the minimal latency. Memory, although slower in comparison, still provide relatively fast access time. However, accessing data from memory involves additional steps like fetching data from the main memory module and transferring it to the CPU register. If we look at the uses, then registers are used for a quick access to frequently use data during program execution. They play a crucial role in execution instruction and performing arithmetic and logical operation. They also store intermediate result and control information from the CPU. Memory, on the other hand, serves as a large and persistent storage space for a program. It holds the program code, variables, array, object, and other data structures. Now, moving to the next, we can talk about the basic assembly programming construction. In this, there are 5 points that we have to discuss. Let us discuss about this all one by one. So first, we will discuss our level. A level are used to store a specific location in the code, often used for creating jump command. Second, comments. Line of the text that are ignored by the assembler, used for documenting the code. Next is directives. Instructions for the assembler to generate code or data in a specific way, like allocating memory or defining constant. Instruction. Command that perform operations such as storing a value in register or performing a calculation. Next, we can discuss about the compiling and running assembly code. So in this context, we can say that assembly code must be compiled into a machine code before it can be run. This is done by using an assembler. This translates assembly code into a machine code that can be executed by the CPU. Once the machine code is generated, it can be run directly by the operating system or loaded into a device. So here in this figure we can see the assembler, machine code and the running program. This three step. The assembler is a software tool that translates human readable assembly code into the machine code. After the machine code is the binary representation of the program that can be executed by the CPU. And the code which are written by the user is uh, is converted from a assembly level to a machine level through assembler. Then after that it is sent for the compilation. The compiled program can be run directly on a computer or loaded into a microcontroller or other devices. Moving to the next, we can see about the example of the assembly program. First, simple arithmetic. An example program showcasing basic arithmetic operation in assembly code. Serial communication. An example of serial communication between a microcontroller and a computer using assembly code. LED blinking. Program to blink an LED connected to a microcontroller using assembly code. File input output. A program demonstrating file input output operating is an assembly code. Now next, there are some instructions in arithmetic in assembly language programming. So in this, there are many, but we will discuss about two. That is data moving in arithmetic operation and branching and conditional execution. So data movement is used to move data from register to register or from memory to register. So assembly language provide instruction for moving data between register and memory. Arithmetic and logical operation can be performed directly on register and memory. So in this context, we can see the example like move a comma b. This means that we are moving the content of b into the accumulator. Now next is branching and conditional execution. So in this assembly language include instruction for conditional execution and branching based on certain condition. Branch instruction can branch instruction can change the flow of programming execution. In this we can see the example of JMP, which is used to jump from the one memory location to the another memory location. Here there are some instruction in assembly language like move. The syntax of move is MOV destination source. This means that if we are using move, this means that moves the content of the source operand to the destination operand. After that, add. Add is used to add two operands. Subtract is used to subtract one operand from the another. Jump is used to unconditionally transfer the program execution to the specific destination address. Now moving to the next, we came to the conclusion. So the conclusion, in this conclusion we can discuss about summing up. Assembly language is a powerful tool in the hand of experienced developer, offering low level control and high performance. Challenges which can be faced in this is the downside of a assembly language that it requires a higher degree of technical expertise and can be time consuming. Looking forward, the next step is to explore the various applications of assembly programming such as device driven development, operating system and security software. So this was all about assembly level assembly programming language. So here we come to end. Thank you for